In just a few months, multiple volcanoes erupted across the Pacific. Taal in Philippines, Merapi in Indonesia, Savanke in Peru, and Sangay in Ecuador. At first, this eruption seems like isolated disasters happening in different countries. But when you plot them on a map, along with hundreds of volcanoes that aren't erupting, a remarkable pattern begins to emerge. Almost all of them lie within a single, enormous belt that stretches nearly 40,000 kilometers around the Pacific Ocean. And it's not just volcanoes. Most of the world's largest earthquake and many of its most destructive tsunamis also occur along the same belt. So why is one narrow belt around the Pacific Ocean responsible for most of the Earth's volcanoes, earthquakes, and tsunamis? For thousands of years, volcanoes have fascinated and terrified humanity. The word volcano comes from Vulcan, the Roman god of fire and blacksmith. Long before science could explain them, many people believed these fiery mountains were the work of angry god or monsters living beneath the earth. During the 1800s, geologists began carefully mapping volcanoes around the world. As more and more volcanoes were added to their maps, an extraordinary pattern started to emerge. Take a look at this map of 1862. It traces chains of volcanoes through the Philippines, Japan, and along the western coast of North and South America. Even without modern technology, scientists had already recognized that these volcanoes were not randomly distributed. They often formed a vast belt surrounding the Pacific Ocean. But one crucial question remained unanswered. Why were so many volcanoes concentrated in this one region? After decades of discoveries by geologists, geophysicists, and oceanographers, scientists finally began to piece together the answer. By the 1960s, they had reached a remarkable conclusion. The Earth's outer rigid shell, known as the lithosphere, is not one solid piece. Instead, it is broken into a series of massive slabs called the tectonic plates, which were constantly moving. The place where these tectonic plates meet are known as a plate boundary. As we plot the world's volcano and major earthquakes, you will notice that they almost perfectly trace the boundaries where tectonic plates interact. But simply knowing where tectonic plates meet doesn't explain why volcanoes form there. The answer lies beneath the Earth's surface. When two tectonic plates collide, the denser oceanic plate is forced beneath the other in a process called subduction. As it sinks deeper into the Earth, magma forms and begins to rise. When that magma finally breaks through the Earth crust, a volcano is born. But the plates don't always move smoothly. When they suddenly slip, they release enormous energy, triggering an earthquake. And if that happens beneath the ocean, it also generates a tsunami. Now what's the northwestern edge of the Pacific Ocean? As it collides with the neighboring plates, volcanoes and earthquakes begin to appear along the boundary. This same process is repeated all around the Pacific Ring of Fire, creating some of the most active volcanoes in earthquake zone on Earth. But what makes these natural hazards truly dangerous is that despite all our scientific advances, we still cannot predict exactly when the next major earthquake and volcano will strike. But there is something we can do about. In Japan, some buildings are designed to sway during earthquakes instead of collapsing, while a nationwide earthquake and tsunami warning system can alert millions of people within seconds. In Chile, one of the world's most earthquake-prone countries, strict building codes introduced after devastating earthquakes have dramatically improved the resilience of modern structure. Nature may be impossible to control, but knowledge, preparation, and engineering have the ability to save countless lives, and they will continue to shape how humanity lives along one of the most powerful forces on Earth.